Welcome everybody. This is Jay and I'm here to show you how we add polynomials. There are two different ways and I'm going to show you four different examples, different levels of difficulty, and show you both techniques that are used so that you are familiar with both and can choose which one you like or prefer to use the best. Okay, so first let's look at this example and we're going to add the polynomial vertically. So when we add vertically, we look at like terms. Like terms would be terms with the same variable and same exponent. For example, 8y to the third power and 6y to the third power are like terms. So when we add vertically, what we do is we want to put the terms into columns and we order them with the highest exponent to the left and the lowest exponent and eventually just the number to the right. And we put them in a vertical column like it shows here. And then we just add the terms. When we add the terms, remember, we're really just adding the coefficients. For example, 8 plus 6 is 14. So we get 14y to the third. Similarly, like with the numbers, we have a plus 3 and a plus 1, so we get plus 4. With the y terms, we have a negative y and a negative 4y. When we add two negative numbers, we add the numbers and keep the sign the same, so we get negative 5y. Look at your y squared terms. We have minus 7 plus 2. Being careful with our signs, we get negative 5 y squared. And then we have the y cubed terms. So we have 8y cubed plus 6y cubed, and we get 14y cubed. Now at this point, we've added the polynomial completely. There's no further simplification to do because all the terms are now different in the final answer. Let's try another example. This one is similar. However, it's very important to look at what terms are like and what terms are not like or are unlike. So again, we follow the same procedure, and being careful, we put the two polynomials in column form, and we make sure that we align the like terms. For example, see how 7n cubed has no other term underneath it because the second polynomial has no cubed or term raised to the third power. Similarly, with the n squared term, there's nothing aligned with that because the first polynomial has no n squared term. Once we have them aligned correctly, now we can add by column. So with the numbers, we just have 12. With the n terms, we have 2n minus 9n, which will give us negative 7n. With the n squared terms, we just get n squared. And with the n cubed terms, there's only one of them, so we just get 7n cubed. And this gives us our final answer. We cannot combine any further because all the terms are now different and we don't have any more like terms to combine. So this is our final answer. Now let's look at a similar example, except this time we're going to add the polynomials horizontally. So it's a second method instead of adding vertically. For this, we write the two polynomials out and we separate them using parentheses, and we put a plus sign in between them. Now we look for like terms, and always start with your highest exponent. So the highest exponent is 4, and we have 2n to the fourth minus 5n to the fourth. So think to yourself, 2 minus 5, we're going to get a negative 3. So we have negative 3n to the fourth. Now look at your next two terms with the next highest exponent, and that will be the terms with the exponent of 3. It's minus 7n to the third and minus 8n to the third. Being careful with your signs, remember when we add two negative numbers, we just add the numbers and keep the same sign. So we get negative 15n to the third. And then last, look at our two numeric terms, minus 4 plus 10, and we get plus 6. And that's our final answer for this problem. We cannot combine like terms any further. Let's do one more example, adding polynomials, and we'll use the horizontal method again, just for extra practice. Again, we take the two polynomials, we separate them with a plus sign, and we put each polynomial in parentheses. Now, start with your highest exponent, and that will be the 3. So we have 7p to the third power. Are there any other terms with an exponent of 3? There are not. So we just leave that in our problem. We just leave it as 7p to the third power. Well, what's the next term? We don't have any with an exponent of 2, but we do have some p terms, right? We have a minus 9p and a plus 5p. Minus 9 plus 5, we will get negative 4, being careful with our signs. So that means negative 4p. And then minus 4, minus 1, add the numbers, we get 5. Keep the sign the same, so it's negative 5. And that's our final answer for this problem. I hope you found this helpful. If you do, please subscribe to my channel at Jay's Math Gymnasium for similar videos to help you with your algebra learning.